So today we're going to look at doing a little bit of practice in standard form graphing and also converting between standard and vertex form. So you've already practiced going from vertex form and foil into standard form. Today we're going to start in standard form and see if we can get into vertex form. So it says we will use the a value and vertex of the parabola to convert equations from standard form into vertex form. Next unit, we will learn the completing the square method that does the same thing. So remember, A has the same role in both of our equations, right? It's the concavity and the vertical stretch. So what would be the steps? If we wanted to take this equation, which is in standard form, and put it into vertex form, what we should do first is say that, all right, we know the A value is going to be the A value of vertex form. So A is -1, B is -6, C is -11. So I'm just identifying those parts from this equation. So the A value I'm going to come back to. That's going to be part of my final answer because that is the A value for vertex form. So now I'm going to do -b over 2a to find the vertex of this parabola. -b is +6. 2a is -2. So that gives me -3 as the x value. So now I'm going to take -3, and do you remember how to find the y value? You're going to plug -3 in for x up here. It's -3 squared minus 6 times -3 minus 11. So it looks like I get -9 here, because even though I square the -3 and it becomes positive, there's a negative in front in the original problem. So -9 plus 18 minus 11 gives me how much? Looks like -2, because that's -20 and +18. So hopefully you're trying this mental math to get stronger at it. So now I know my A value and I know my vertex. So I should be able to write my equation in vertex form. Y equals negative or -1 parentheses. How am I going to go to the left by 3? X plus 3 squared. How am I going to go down 2? -2. Left 3, down 2, a value of -1. So that is my formula in vertex form. If I graphed this or I graphed this, I get the same exact thing. So let me just show you how, if you have a calculator, you could check your answer. -x squared minus 6x minus 11, put that into equation 1, negative parentheses x plus 3 squared minus 2, and if I hit zoom 6 or I just hit graph, those graphs should go right on top of each other. If they don't go on top of each other, I've done something wrong. So it's hard to see that now it's red and blue, but it did blue first and then it put red over the top. So they came out as the same graph, so I know I got it right. All right, so example 2. What is the A value this time? So the A value is 1, so I need to know that. I'm going to do my -b over 2a, gives me -5 for the x value of my vertex. Now I'm going to plug in -5. So -5 squared plus 10 times -5 plus 35. So that gives me 25 minus 50 plus 35. That looks like 10, right? Because this together would be 60. 60 minus 50 is 10. So -5 comma 10 is my vertex, or check it on a calculator, right? 25 minus 50 plus 35. All right, so my function would be, A is 1, so I could either write a 1 there or I don't have to. If I want to go left 5, I do x plus 5 in parentheses. If I want to go up 10, I put a plus 10. So 1, or you could just leave that blank, x plus 5 squared plus 10 should be the same quadratic that I started with. So we might as well just check our work. X squared plus 10x plus 35 and parentheses x plus 5 squared plus 10. So let's graph and see if they showed up on the same axis. Oh, I just realized that if my y-intercept is at 35, I might have to change my window. Let's make the x max of 100 and just see if we can zoom out. Okay, so here's my first parabola. And make sure my other parabola is right on top of it. And it is, it's red now. It's hard to see. All right, the next example. A is -3, so I need to know that A is -3. I'm going to do negative B, so positive 12, divided by 2A. 2A is -6, so that would be -2. -3 times -2 squared minus 12 times -2 minus 12 again. That's a lot. Let's see. -3 times +4 is -12 plus 24 minus 12. Is that 0? -2 comma 0? So y equals -3 times x plus 2 squared plus 0. All right, let's double check. That seems a little bit unusual, but maybe it came out that way. -3x squared minus 12x minus 12 compared to -3x plus 2 squared. I hope I did it right. If not, you'll see right now if I made a mistake. All right, it did trace back over itself, so that was the correct vertex form equation of this standard form equation. So on the back here, I put 2 more examples to do together of graphing in standard form. And then you've got this practice page, you've got 4 parts on this 213 guided practice to do on your own to submit today. So let's do example 4 and 5 together. So remember, your first step is to identify A, B, and C. A is 1/2, B is -2, and C is 0 in this problem. So let's see, 1/2, it's going to be concave up, and it's going to be a shrink. So remember, when you do a shrink, you take your parent point, so 0, 0, 1, 1, 2, 4, 3, 9, and you shrink all those y values. So if you multiply the y values times 1/2, you'd be at 0, 0, 1 comma 1/2, 2 comma 2, and 3 comma 4.5. So I just shrunk the y values, but the x values stay the same. All right, so I'm going to go back up here. I need to do -b over 2a. So -b is going to be +2. And 2 times a, 2 times 1/2 is just going to be 1. So the x value of my vertex is 2. Then I'm going to plug 2 into the original equation up here. So I'm going to do 1/2 times 2 squared minus 2 times 2 and evaluate that. So let's see, half of 4, right, 4 is 2, minus 4 would give me -2. So my vertex looks like 2 comma -2, and I'm doing these parent points that have been all shrunk and it was concave up. So over 1 up 1/2, over 2 up 2, hey, my C value was 0, got 0, 0 as a y-intercept, over 3 up 1, 2, 3, 4.5. So how's that look? Parent function that's been shrunk by 1/2. All right, the last one for today for doing together, and then you can try the guided practice on your own. Let's see, A is 1, B is -2, C is 1. Concave up parent function. Need to do the -b over 2a. So negative b over 2a is going to be positive 2 over 2 times 1 is positive 2. So 1 is the x value of the vertex, and I'm going to plug it into that function. So 1 squared minus 2 times 1 plus 1. 1 minus 2 plus 1 is 0. So 1 comma 0 is my vertex. And this is a parent function concave up. So over 1, up 1, hey, I just hit my y-intercept. C was 1, checks out. Over 2, up 1, 2, 3, 4. And over 3, up 9, 9. All right. So you've got this guided practice of 213 to work on and send me. Good luck. Have a great day.